Numbers. What are numbers? Numbers are the thing we count with. And what do you make numbers of? You make numbers out of digits. The digits we have are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are in total, whip-a-dip. How many? Yes, 10 digits. The interesting with saying that you have 10 digits is that to say that you have 10 digits, you have to do your first combination of them, and we get the number 10, which is 1 and a 0. Very simple stuff. In mathematics, we use different number systems to count for things where other number systems aren't enough. You have the natural numbers. Natural numbers. These are the ones we just mentioned. Sometimes you include the 0 and sometimes you don't. But this basically consists of whole positive numbers. 1, 2, 3, 4, up to an infinite amount. All the whole numbers. The things you can count cows with. Like we have 3 cows on the meadow. You don't have 2.5 cows unless a murder's been there. So next up, we have the whole numbers. The whole numbers. I think you say whole numbers. Oh, no. The English phrase is integers. The integers. The integers. Integers. And this include the whole numbers and the negative ones. So you got all the negative ones in all directions. You got 0. You got 1. You got 2. You got 3. And up to infinite in both directions. So when you lost the cow from the meadow, when you had 3 cows, and then you lose a cow, you get 3 plus minus 1 cow. I don't know why I count in cows, but it felt good right now. I played Minecraft recently. So the integers involve positive and negative natural numbers, like the whole numbers. Those are the integers. Then you have the rational numbers. Oh, I should move that down a little bit because I want some more space for the next one. Let's place it here. That would be perfect. We can move up a little. We have the rational numbers. Rational numbers. These are divisions of this. You make this by dividing integers with each other. So the rational numbers have some examples. You have numbers like 6 over 2, 3 over 4, 7 over minus 23, and so on. Like if you have, whoops, can we have a look at so minus? I wrote it outside the screen. That was not good. 7 over minus 23. We could also have really, really huge numbers divided by each other. So the rational numbers are integers on top of each other to make divisions. Obviously, you can count with these and simplify this. So this would be equal to 3. You also have the real numbers. Choop. That was not very nicely written. Real numbers. these involve all the numbers on the number line. So if we make a little number line here, oh, I shouldn't start in a place like that. So we have 0 in the middle, and then it goes infinitely in this direction, and infinitely in the plus direction, and infinitely in the minus direction. You might see this in a graph, for instance. And real numbers contain all possible numbers there is. And the difference between all these other numbers we just mentioned and the real numbers is that if you would place these numbers on the number line, there would be numbers between those numbers that were missing. So for instance, if we place the natural numbers on the number line, like this, we got 1, 2, 3, and so on, you realize directly that you miss all the negative numbers. Okay, let's add the negative numbers. So we have the integers as well. If we do that, we get -1, -2, -3. Great! We have all the positive numbers and the negative numbers. But we realize that we still miss some numbers on this line. For instance, we don't have a half, which is here. So if we add a half, we get 1/2. And so we have to add some rational numbers to get 1/2. But an interesting thing with real numbers that there are actually some numbers here that you can't even write as rational numbers. So there are still some, you could call them holes on the number line that the rational numbers can't even help to fill out. And those holes are filled with real numbers. So the real numbers contain all the possible numbers on this. The most famous one of these, I would say, it's the number pi, which is approximately 3.14, and then a lot of infinite decimals because you can't really write them out there. Oh, I should make a little move here because I realized that I've been writing outside of what you can see. Can we take all this? Whoops. All this. Oh, yes. Oh, yes. Make a little copy. Then just paste it down here. Then you have the 0 in the middle here. That's better. Much better. Real numbers. So, recap. We have the natural numbers, which are the numbers you can see in nature. You can see 1 thing, you can see 2 things, you can see 3 things, you can't see 0 things. You have the integers, which involve the natural numbers and the negative counterparts of those numbers and 0. So this is very good for accounting for things like, you owe me 5 coins because I lended you and now I have -5 coins. It's like a made-up concept of something that's missing. Not really natural in the same way, but very important within mathematics. And then you have the rational numbers when you divide the natural numbers between, like, you have 1 pizza and you divide it with 4 friends. Then each of those friends gets 1/4 of a pizza. So if this is the pizza, ta-da, each get a piece like that. Delicious, isn't it? And then you get the real numbers that involves all the numbers available on the number line. And as you notice that when we placed the other systems of numbers on the number line, we constantly had to add more numbers. So the natural numbers weren't enough. So we had to add the integers, but they weren't enough. So we had to add the rational numbers, but they weren't enough. So we also had to add the numbers in between the rational numbers to get all the real numbers. And that's why pi is a real number and not a rational number. You can prove it more mathematically to make sure what it's about, but that's for another video. Oh, I think that was that. Thank you so much for watching. I'm still practicing at this. I'm trying to learn new ways in how to present mathematics, and it's kind of fun. I'm more used to do it like in person, but I think this works as well. Please give me some feedback. Please give me some problems that you might want some help to solve. I'd gladly help you. And good luck with your studies. I'm going to do some more complex stuff. This is just me basically practicing my presentation. But now it's been 10 minutes and I'll see you in the next video. Goodbye.